Let's learn how to draw circles in perspective. They are also called foreshortened circles, ellipses, call them whatever you like, but every rounded circular object, plates, mugs, vases, you name it, columns, if you will go and draw architecture, they obey the same principle as perspective. Things that are a little bit farther of the same size appear smaller as they recede from our sight. And we're going to explore this phenomenon on the example of the familiar to you square. So we have mastered somewhat the perspective of the rectangular objects, squares, boxes. And let's imagine that we are dealing here with the square. It can be something like a tile, for instance, in the middle of which there is a circle. In order to draw a proper circle inside of a square, you need to find its center, the center of the square. In order to do that, you connect the opposite corners with diagonals. Freehand works fine normally, not while shooting the video on a computer, and I can help myself a little bit with the ruler. So now we have a center, and drawing a cross through the center, we will get the diameter. I hope it's perpendicular. And the rest will be very easy. So of course you can draw as many straight lines now through the center in order to help with finding the perfect curvature for your circle. And then you take the radius and you can put it everywhere. I'm going just to try to do it freehand, round it up. It will be proportionate. It might need a little bit of improvement eventually, but I'm going to be satisfied. Now it looks like a slice of an orange. There you go. And now we're going to put this tile flat on the floor. It's standing upright. We want it down. Here is the front of the tile of the same size. In order to put this flatly down in one-point perspective for the ease of demonstration, I need to create somewhere an imaginary horizon line. This is a simulation, it's not the real thing. So we can just speculate. And then from the center, shoot the straight line, which will become a vanishing point. Just like when we were drawing a cube in perspective. After that, we connect the dots. I missed a little bit because of the shadow, so I'll just lower it. It will be here. And then let's decide how wide we want this tile. I want to be able to draw the circle in it, so I'll make it about like that. And this becomes our tile in perspective. I hope you agree. It looks pretty credible. Now let's repeat the steps in order to find the center of this position of the tile. We need to connect opposite corners with diagonals. This point becomes the center because it is foreshortened. There is a distortion due to perspective. In real life, this side is as big as this side, obviously. But because of the visual illusion, the perspective phenomenon, we perceive this part shorter, this part longer. But nevertheless, we can now draw the line across. We already have this. And we have the reference for our ellipse or foreshortened circle. So I will draw firstly freehand like that. And of course, this part should equal this part of the radius, but it cannot equal this because this is bigger. This part of the tile with a circle is closer to our eye, but this, of course, should be equal to this. In order to build this correctly, with greater accuracy, to find out exactly where those points might be, there is a little interesting trick that I'm going to show you. You need to divide first half in half, so we have quarters now, and draw a square of where the side is of the length of this quarter. Then you draw diagonal, just one. Take this diagonal, measure it, and from the center apply, well, you see, I was so close, almost precise, and do it on the other side. Then, through this point, connect to the vanishing point, and of course on this side too. And where you have intersections with these diagonals, that will be the point where the curve touches them. So that is how you create perfect symmetry. Of course, you do not have to do this every time you draw a plate or a mug or a rim of some kind of a vessel. But this helps you to understand and remember that in any position of the foreshortened circle, whatever it is, there is always the same ratio. This part will be 48%. This part will be 52% of the 100% width. That is what is important. If we will imagine that this is some kind of a jar, it will be a short jar. I want it to fit into my demo paper. Jog. And we can see the bottom. It will be more scooped, let's say it's transparent, than this. So this will become rounder. If it goes lower relatively to your horizon, which is here. It will become rounder and rounder and rounder. It opens up, you can look in. And if this grows all the way up, it will become flatter. The opening will be flatter, flatter, and flatter. On the horizon, you will see straight line. When you look a little bit down, when you lower this thing, and you see the opening of the vessel, doesn't matter how narrow can it be, there will be still the same relationship, percentage, which in exaggeration looks like that. The lower scoop is always rounder, the farther part always flatter. So as I said, this is an exaggeration, but it should show you how to look at things properly and perceive them as they are, not as you think they are. Because a child would draw a mug like that. While in fact, when we look at the mug and know all that, it's like that. Rounder bottom, flatter, much flatter on the other side because of the perspective.